Let me say right at the start that we clearly made a serious error. Mars Climate Orbiter was on the wrong trajectory, and our checks and balances did not reveal that error.
A single equation destroyed a $327 million spacecraft. Not a meteor, not an alien invasion, just a math mistake. NASA's Mars Climate Orbiter was supposed to be a groundbreaking mission, a key step in understanding the red planet's climate. Instead, it became one of the most expensive blunders in space history. But was it a simple oversight or a deeper failure in communication and precision?
Poor training, poor communication, cockiness, and a whole bunch of other not good things.
Let's break down the $327 million lesson NASA and the world learned the hard way. In 1998, NASA launched the Mars Climate Orbiter, a sleek, state-of-the-art spacecraft designed to unlock the mysteries of the Martian atmosphere. It was supposed to be a key player in NASA's ambitious Mars Surveyor program, a long-term effort to study the red planet and prepare for future human exploration. Scientists envisioned it as a kind of interplanetary meteorologist, tracking dust storms, analyzing weather patterns, and even helping future rovers and landers communicate back to Earth. If we ever wanted to set foot on Mars, we needed to understand its climate first. The mission had all the markings of success. The spacecraft itself was built with precision, equipped with cutting-edge instruments, and launched flawlessly aboard a Delta II rocket. It was a triumph of engineering and scientific ambition. But hidden beneath the layers of careful planning and technological prowess was a single, almost trivial mistake, one that would ultimately reduce this $327 million mission to nothing more than a cautionary tale. Precision is everything in space travel. A fraction of a degree off course can mean missing a planet entirely or crashing into it at thousands of kilometers per hour. Every calculation, every maneuver must be perfect. There is no room for error. But sometimes the biggest disasters don't come from catastrophic system failures or dramatic explosions. Sometimes they come from something as simple as forgetting to convert feet to meters. If you're enjoying the video, don't forget to hit subscribe. We're aiming for 500 subs by the end of the year, and your support would mean a lot. Thanks for being here. For the Mars Climate Orbiter, the fatal mistake was buried deep in the numbers, so small, so seemingly insignificant that it went unnoticed for months. NASA's navigation team was working in metric units, using Newton's seconds to calculate the spacecraft's trajectory. But Lockheed Martin, the contractor responsible for the spacecraft's thrusters, was using imperial units, pound seconds. To most people, these terms mean nothing. But in physics and engineering, they define the very forces that guide an object through space. One system, metric, is based on the properties of water and universal constants. The other, imperial, is built on centuries-old conventions and arbitrary measurements. When the two collide, things go wrong, very wrong. At first, the impact of this mistake was subtle. Each small course correction, each minor thrust was slightly miscalculated, leading the orbiter down a path that wasn't quite right. The errors compounded over time, accumulating like a growing snowball rolling downhill. Weeks before the spacecraft reached Mars, NASA engineers noticed something was off. The trajectory wasn't matching their expectations. The orbiter was drifting lower than planned. Engineers flagged the issue, raising concerns that it might enter the Martian atmosphere too steeply. But these warnings were dismissed. The deviation didn't seem significant enough to cause alarm. After all, this was NASA, a place where brilliant minds checked and double-checked everything. On September 23, 1999, after a journey of nearly a year, the Mars Climate Orbiter reached its destination. It was supposed to perform an orbital insertion maneuver, dipping into the Martian atmosphere before settling into a stable orbit. Instead, the spacecraft came in far too low, 57 kilometers lower than planned. At that altitude, there was no room for correction. Instead of gently skimming the upper atmosphere, the spacecraft plunged deeper and deeper until the forces of Mars's thin air tore it apart. Back on Earth, engineers watched in horror as their signals with the orbiter suddenly ceased. In a matter of seconds, the mission was over. There was no dramatic explosion, no spectacular crash, just silence. A $327 million spacecraft had been reduced to a mathematical error, lost forever in the vast emptiness of space. The most tragic part? This mistake wasn't caught after the crash. It had been noticed weeks before. The data had been there, the inconsistencies had been flagged, but a combination of overconfidence, miscommunication, and bureaucratic inertia allowed it to slip through the cracks. It wasn't just a conversion failure, it was a failure of teamwork, of organizational structure, of critical thinking. This wasn't the first time human error had doomed a space mission, and it certainly wouldn't be the last. But what makes the Mars Climate Orbiter disaster so infamous is how avoidable it was. The loss of the Mars Climate Orbiter had immediate and profound consequences for NASA and the scientific community. The mission ended in total failure, marking one of the most significant blunders in space exploration history. The $327 million investment, which encompassed years of research, planning, and engineering, was rendered worthless. The failure not only set back scientific progress, but also strained relationships between NASA and its contractors. Questions arose about accountability, oversight, and the protocols that allowed such a basic error to slip through the cracks. In response to the disaster, NASA implemented crucial changes to ensure that a similar mistake would never happen again. One of the most significant adjustments was the standardization of units. NASA mandated that all calculations and engineering specifications be conducted using metric units. This decision aimed to eliminate the confusion caused by the previous dual use of metric and imperial units. The failure of the Mars Climate Orbiter has transcended its immediate implications, becoming a cautionary tale that is frequently referenced in STEM education. It illustrates how even the most advanced technology and brilliant minds can falter due to fundamental miscommunications and oversights. Educators use this story to teach students about the importance of precision, the need for rigorous standards, and the critical nature of collaboration in scientific and engineering projects. As we continue to explore the cosmos and venture into uncharted territories, let us carry this lesson with us, ensuring that we remain vigilant, precise, and committed to excellence in all our endeavors.